Hi, welcome to day 3 of summer school, where we are going to focus on identifying, analyzing, and writing geometric sequences. That's our learning target for today. So let's start with some information about what geometric sequences are. Geometric sequences are sequences in which the ratio between any two terms is constant. So with arithmetic sequences, we were looking at the difference. And to find the difference, we had to subtract the two terms. For the ratio, now we want to divide. So a geometric sequence is a sequence in which that ratio between any two consecutive terms is constant, or is the same. That common ratio is the numerical ratio between any two terms. And just a reminder that ratio means to divide, and we use the variable r to talk about the common ratio when we're writing our formulas for sequences. So let's look at this first set of examples. In the directions, it asks us to determine whether the sequence is geometric. If yes, identify the common ratio and give the next three terms. So let's take a look at example number 2. And to find our ratio, we want to take the second term and divide it by the first term. So if you take 270 divided by 810, 270 divided by 810 is 0.3333, which is 1/3 for our ratio. Well, let's look. If we take 90 to 270, that also has a ratio of 1/3. If we take 30 to 90, that has a ratio of 1/3. So yes, this is a geometric sequence. That common ratio is 1/3. And then to find the next three terms, we want to continue multiplying by 1/3. Which is the same as dividing by 3. So the first, or that next term in our sequence would be 30 times 1/3, which is 10. Then we take 10 times 1/3, which is 10/3. Then to get to the last term, we take 10/3 times 1/3. And what happens there is that the denominators multiply together. So the 3 and the 3 become a 9. So that would be the next three terms. So let's look at example 4. If I take 8 divided by 4, we get 2. Take 20 divided by 8, we do not get 2. So this is not geometric because they have a different ratio. Okay, let's look at number 6. Why don't you guys take a minute and try number 6, and then pause the video and come back when you're ready, and we'll go through number 6 as a check for accuracy. You can pause the video now. All right, let's take a look. 4 divided by 2 is 2. 16 divided by 4 is not 2. So this is not a geometric sequence. Go ahead and try number 8 as a check for accuracy as well. Go ahead and pause the video now, then come back when you're ready to look at your answer. All right, let's talk through number 8. If I take 8 divided by 3.2, we have a ratio of 2.5. 20 divided by 8 is 2.5. 50 divided by 20 is 2.5. So yes, this is an arithmetic sequence. To find the next three terms in our sequence, we would have to use our common ratio, which is 2.5, and continue to multiply. So we take 50 times 2.5, which is 125. Then we're going to take 125 times 2.5. You get 312.5. And then if you multiply that again by 2.5, you get 781.25. All right, that gets us through the first 4 examples for today. Part of your work today will be to complete the odds of this section. If you'd like to do so now before moving on, you may. When you're ready, go ahead and come back and we will move into the next section. All right, let's take a look at the formula for finding a geometric sequence. So in a geometric sequence, the formula can be found. So the nth term is equal to the first term times the common ratio to the n minus 1 power. Notice that that's an exponent. Repeated multiplication becomes exponents for us. So a sub 1 is still our first term, and r is that common ratio. So let's look at number 10 as an example. We want to write a rule for the sequence, then find the 6th term of the sequence. So the first thing we need to do is figure out what that common ratio is. So if I take 65 divided by 130, 65 divided by 130 is 0.5, which is 1/2. So that is our common ratio. Our first term is the first number in that sequence. So then the rule for our sequence, a sub n, is our first term, 130, times 1/2 to the n minus 1 power. So to find the 6th term, we want to take 130 times 1/2 to the 6 minus 1 power, which would be 130 times 1/2 to the 5th power. I would use your calculator to get to that point. Anytime you have parentheses in your expression, you should put those parentheses in your calculator as well. And you can use division to do that fraction. So you should get 4.0625 as your 6th term. All right, let's take a look at number 12. Oops, we're skipping 12. So your task is to do problems 9, 11, and 13 in that section to get practice with those. So you can either pause now and come back when you're done, or you can finish it up later as part of your independent practice for today. All right, let's take a look at this next set of information problems. So I'm going to do number 17 as an example for you. And your task is to do number 15, to use the given information to find the indicated value. So in number 17, we're given the first term of the sequence and the 4th term of the sequence. And we want to find the 3rd term of the sequence. Well, to figure out how the sequence is working, we need to figure out what that common ratio is. So I do know that my first term is 13. I don't know what my common ratio is, but I know that the 4th term is equal to 4,459. So we can use our formula to help us find that common ratio that we can then use to find the third term? Well, solving this equation takes a little bit of is a little bit challenging. We want to get the ratio to the exponent by itself first. So I'm going to divide both sides of our equation by 13. Then we would get the ratio to the third power, because 4 minus 1 is 3, is equal to 4,459 divided by 13, which is 343. Now, to undo an exponent of 3, we want to use the third root of 343. So we're figuring out what number to the third power is 343. Now, finding the third root is different on every calculator. In Desmos, you should be able to find the third root in Desmos if that's the calculator you're using. And the third root of 343 is 7. So to find the third term, we've got a couple of different options we can use. We can use the formula to get there, since we now know what that common ratio is. So the first term is 13. The common ratio is 7. We want to find the third term. So we want to take 13 times 7 to the second power. So 13 times 7 to the second power is 637. All right, your task is to do number 15. Make sure that you are paying attention to find the value of the 8th term. When you're done, you can come back here and we'll go through the application together, or you can wait until the end to do the independent practice. All right, here is our application. Jackson brought a brand new car for $38,000. If the car depreciates in value by 20% each year, what will the car be worth in 8 years? Well, if we think about this as a sequence, 38,000 would be the first term of the sequence. And when we're depreciating by 20% each year, that means that we are retaining 80%. So that's our multiplier, is that 80%. So we're going to use that as 0.80 after converting from a decimal to, or from a percent to a decimal. So 0.80 is our common ratio, and we want to know what that's going to be worth in 8 minus 1 years. So 38,000 times 0.8 to the 8 minus 1 is 7th power. And you should get $7,969.18. That's what that would be worth after 8 years. All right, to wrap up our conversations about sequences, we're going to take some notes to kind of summarize the big ideas. We're also going to talk about a different type of notation that you might see that looks more like function notation. It works exactly the same way as the A notation we've been using. It's just a little bit different, so you might see things both ways. In both cases, the term number, so it's the position in the sequence, would be n. And if I wanted to talk about the nth term, I could talk about that as a sub n, or if I use more of this function notation, I could say t of n would represent the nth term in the sequence. The previous term would be a n minus 1, or we could have it as t of n minus 1. Now, when we are looking at a recursive formula, there are two pieces of information that we have to define for a recursive formula. We need to define the first term, And we're going to need to talk about that common difference. So when we are looking at the notation we've been using, we would have two pieces. We would have the first term, and we would define that term, and then we would give a rule for finding the nth term. And to find the nth term, we take the previous term, the an minus 1, and we add our common difference. Now, if we were looking on the other side of things, we would have t of 1, and we would define what that first value in the sequence is. And then we would say t of n equals t of n minus 1 plus that common difference. The explicit formula for arithmetic sequences, now we're going to need to put a1 into our formula and the difference into our formula. So there's two pieces that you're going to have to use as you're writing this information. So in the explicit formula, the nth term is equal to the first term plus the common difference times n minus 1. And for the arithmetic formula for the explicit side of things, we would say t of n equals the first term, so t of 1, plus the difference times n minus 1. All right, let's look at the recursive formula for a geometric sequence. When we're talking about the recursive formula, we're going to need to define that first term, and we're going to need to talk about what that common ratio is. So in a recursive formula, we would have to define our first term, and then to get the nth term, we're going to take our previous term, so a times n minus 1, times our ratio. In the t of n notation, we would have our first term, and then the nth term would be equal to the previous term times the common ratio. For the explicit formula, now that first term, so that a sub 1 and the common ratio are going to have to be known to write your equation. So the nth term is equal to the first term times the common ratio to the n minus 1 exponent. In the other notation, we would say t of n is equal to t of 1, that's that first term, times the common ratio to the n minus 1 exponent. The 52nd term for each of these would say a of 52, and we would have t of 52. That would be how you could indicate that. All right, you now should have a brief reminder and refresher about arithmetic and geometric sequences. Please make sure that you take some time to practice. Make sure you do the independent practice, get those uploaded, then do your very best work on that formative assessment. Please reach out if you have questions. I'm happy to help in any way that I can. Thank you guys for a good first week. We'll talk to you on Monday.